Welcome to our channel. Today we will discuss some important MCQ on prestressed concrete. So let's begin. The phenomena of development of internal tensile stresses in a concrete member by means of tensioning devices are called as prestressing of concrete. So the prestressing of concrete is basic concrete in which internal stresses of a suitable magnitude and distribution are introduced so that stresses resulting from external loads are counteracted to a desired degree. In reinforced concrete members, the prestress is commonly introduced by tensioning of steel reinforcement. In RC member, the prestress commonly introduced is by tensioning the steel reinforcement. Which of the following basic concept is involved in the analysis of prestressed concrete member? Combined and bending stresses. The minimum grade of concrete that can be used for pre-tensioned member is M40. The minimum grade of concrete that can be used for post-tensioned member is N30. In pre-stressed concrete member, steel is under tension. Loss of stress due to relaxation of steel is influenced by initial stress in steel. Which of the below structure does not require pre-stressed concrete? Arch. In axially prestressed member, the concrete is under compression. Prestressing is possible by using high tensile steel. Prestressing steel has an ultimate tensile strength nearly 4 times that of HYSD bar. Prestressing is economical for members having long span. Linear prestressing is adopted in beams. Circular prestressing is advantageous in pipes and circular tanks. High strength mixes should have a water cement ratio of 0.3 to 0.4. Creep of concrete in a structural member is due to inelastic strength. Shrinkage of concrete in a structural member is due to loss of moisture and drying of concrete. High tensile steel is basically high carbon steel. In post-tensioning system, the wires are tensioned against hardened concrete. High tensile bar threaded at ends are used in Lee-McCall system. In pre-stressed member requiring very large forces, the tendons preferred are strands. Concentric tendons in a concrete beam section induces uniform compressive stress. Eccentric tendons in a concrete beam section induce direct and bending stress. In a pretension beam, there will be loss of stress due to elastic deformation of concrete. In a post-tension beam, there will be loss of stress due to shrinkage of concrete. The deflection of a pretension beam is influenced by imposed load. Prestressed concrete beam fell suddenly without warning due to failure of steel in tension. The tendons in the pretensioning system are tensioned between rigid anchorages. In the prestressing system, the tendons are first tensioned between rigid anchorage block cast on the ground or a column or a unit mold type pretensioning bed prior to the casting of concrete in the molds. When the concrete attains sufficient strength, which elements are released? Jacks. High early strength concrete is often used in factory to facilitate early stripping, the reuse of mold. And when the concrete attains sufficient strength, the jacking pressure is released and the edge of tendon at its either side is formed to an abutment and its other edge is to be pulled without the application of jack, which is one of the systems used for pretensioning. Hoyer's longline method. Hoyer's longline method is the system used in pretensioning, and the other system like Freycinet, Gifford-Udall and Mangal-Balton are post-tensioning systems, and large number of beams are produced in an individual alignment. Hoyer's system of pretensioning is generally adapted for large-scale members. Hoyer's system is generally recommended when the production of pretensioned members is required on a large scale. Is the principle which I used to precast the beam. The post-tensioning system was considered to pre-tensioning system when used for large span. Due to this reason, the pre-tensioning system was replaced by post-tensioning system. The transfer of prestress of concrete is achieved by jack. The transfer of prestress to concrete is usually achieved by large hydraulic or screw jack, by which all the wires are simultaneously released after the concrete attains the required compressive strength. The bond of prestressing wire in Hoyer system can be formed by helical crimping. Bond of prestressing wire may be considerably improved by forming surface indentations and by helical crimping of wires in Hoyer system. Strands have considerable better bond characteristics than plain wires of equal cross-section area. Supplementary anchoring devices are required when single wire of larger diameter are used in the pretension units. The Hoyer's method of pretesting is done by pulling out of wire. Hoyer's system of prestressing involves pulling out of wire between two bulkheads which are separated at large distances in order to produce a large number of beams in an individual alignment. The Hoyer system of prestressing proves to be economical for post-tensioning system. The post-tensioning system was considered as economical when compared to pre-tensioning system when used for larger span. Due to this reason, pre-tensioning system was replaced by post-tensioning system. If the finishes are to be applied to the prestressed concrete member, the upward deflection should not exceed span by 300. In a pre-tension system, when a wire is released from its temporary anchorage, the end of the wire swells as a result of contraction. In a pre-tension system, when a wire is released from its temporary anchorage on the pre-stressing bed, the end of the wire swells as a result of the recovery of the lateral contraction. The swelling of the wire produces which action on concrete? Radial pressure. How many factors are considered while pre-stressing force in steel is transferred to concrete through bond? 3. The pre-stressing force in steel is transferred to concrete considering three factors through the bond having adhesion, friction, shearing resistance. The bond stress in the pre-stressed member is mainly due to friction and shrinkage. The bond stress at intermediate point is resisted by adhesion. Bond stress at intermediate points is resisted by adhesion and in transfer zone the adhesion is destroyed by invariable slip and sink of tendon into concrete. The steel and concrete reach their maximum values of stress when bond stress is 0. When the bond stress is 0, the steel and concrete reach their maximum value of stress with uniform stress distribution in this section. The term transmission refers to attainment of uniform stress distribution. Prestressed concrete is widely used in construction by nuclear pressure vessel. Prestressed concrete is used in construction of long span bridges, industrial roof, marine structure, nuclear pressure vessel, water returning structure, railway sleeper, etc. Dischinger explained the use of unbounded tendons in the construction of large bridges. Dischinger in 1928 has explained the use of unbounded tendons in the construction of large bridges of deep girder type. The use of prestressed concrete in Europe and United States spread rapidly from 1935. Solid prestressed concrete slabs 600 mm thick have been used in bridge deck for span up to 12 meters. Prestressed concrete shell and folded plate structure are ideally suited for aircraft hangar. Prestressed concrete sleepers should be designed to resist both static and dynamic load. In the design of PSC electric pole, combined bending and torsion developed due to Q-snapping of wire. The importance of using high-strength concrete and high-tensile steel was introduced by President. President in 1928 to 1933 have given the importance of using high-strength concrete and steel in order to various losses of prestress due to creep and shrinkage. In 1907, the losses of prestress due to elastic shortening of concrete was developed by Cohen. In 1888, manufacturing of slab and small beam using embedded tension wire in concrete was introduced by Doring. Which one of the following is the basic assumption involved in designing a pre-stressed concrete member? Plain member remain plain before and after bending. The pre-stressing used for arches and pavement involved the application of direct forces. The concrete member which are pre-stressed by providing the tension tendons are termed as internally pre-stressed member. The linear pre-stressing is mostly applicable for straight members. The failure due to fracture of steel in tension in the beam is because of least amount of reinforcement. If the concrete in tension zone get cracked, will lead to development of tensile stresses. The failure due to fractured steel in tension can be prevented by providing a steel reinforcement is 0.15 to 0.2%. In under reinforcement section failure, the beam observes excess elongation. Due to excess elongation of steel, the neutral axis near the compression phase gets increased. Which type of deflection is observed in compression phase during under reinforced section failure? Large deflection. The over-reinforced section fails due to sudden crushing of concrete. The estimation based on compatibility of the strain of pre-stressed concrete involves flexural strength. The stress-strain characteristics of steel used as pre-stressing tendon are necessary for flexural computation. The failure of pre-stressed concrete member without additional untensioned reinforcement to that of plain concrete is less. The distribution of torsion shear stress is uniform in trapezoidal section. The flexure shear cracking load in a pre-stressed member is given by American Code ACI 318-1981. In which direction the flexural crack are first initiated. Bended. The wave shear crack are developed when the beam is subjected to concentrated load. The wave shear crack generally start from interior point. Which type of pre-stressing is generally uneconomical for vertical pre-stressing? Post-tensioning. How many ways are there for improving the shear resistance of structural concrete member by pre-stressing technique? 3. If the direct stresses are compressive, then the magnitude of principal stresses in pre-stressed concrete member gets increased. If the direct stresses are compressive, then the magnitude of principal stress in pre-stressed concrete member acts in a reduced considerably as therefore under working load. These principal stresses must be compressive in nature in order to eliminate diagonal cracks in concrete. The strength concept can also be used to determine the position of C-line. If the force acts at the lower current point, then the point fiber of the bottom of the beam are subjected to maximum permissible stress. If the section of a rectangular beam is subjected to the pre-stressing force and dead load, then the stress distribution is given by current distance. In the concept of pressure line, the C line moves over a P line due to the effect of moment. The pressure line is also known as C line. In a concrete member, trapezoidal cable profile is adopted when the beam is subjected to concentrated load. The reactions of cable are obtained by replacing the forces acting on concrete. The concept of load balancing is useful in selecting tendon profile. The number of steps are involved in designing a pre-stressed concrete beam of I section is 14. Number of steps involved in designing a rectangular pre-stressed concrete beam are 6. In pre-tension and post-tension member, the value of tensile stress Fp and depth of neutral axis XU is obtained based on effective reinforcement. The code used for determining the ultimate flexural strength of the rectangular section is IS 1343. The ideal cross-section for a pre-stressed concrete pole to resist various types of lateral forces is rectangular. Pre-stressed concrete poles are mass-produced using long line method of pretensioning. Use of pre-stressed concrete in construction results in slender structures. Proper maintenance of pre-stressed concrete structure is important to ensure safety and serviceability during its lifetime. The flexural strength of existing pre-stressed concrete girders can be strengthened by externally bonded plates. The most economical lighting layout which is suitable for narrow road is single side lighting. The maximum limit of water absorption for aggregates suitable for road construction is 0.6%. Pre-stressed high-performance concrete structure experience low creep and shrinkage. The workability of high-performance concrete used in pre-stressed concrete structure is superior to that of ordinary concrete. In precast pre-stressed concrete pipe, the circumferential wire winding is essential to resist hook tension. In the case of precast concrete trusses used for long span, the member to be pre-stressed is bottom tie member. The ideal type of precast concrete element suited for the construction of long span curved bridge deck is cellular box girder. Precast pre-stressed concrete slab in comparison with non-pre-stressed slab result in saving of concrete up to a percentage of 45%. Hope you like our video. Stay tuned for more such videos. Subscribe our channel and like the video. Thanks.